Hi all, welcome back to another lecture of DBMS, and in this lecture we will be learning about what is functional dependency and why the functional dependencies are so important. Then we will see the difference between trivial and non-trivial functional dependencies. Then we will learn about some inference rules and what are closures in the functional dependency. So this video is going to be very much important, so stay tuned and let's begin with the very first topic, which is what are functional dependency. So we have seen in the last lecture also when we're talking about that A or B combinedly defining C or A is defining B, right? So this is what functional dependency means. When we are saying one attribute or one column is defining another column, means the B column is dependent on A, or here C is dependent on A combinedly B, right? So this is what functional dependency means. So it is a constraint between two set of attributes from the database. This means that any two rows in a table, if they have the same value x, they must having the same value y. How? Basically, let's suppose we have a name column and we have a age column also. Let's suppose we have ID and name. Okay. So if in this row we are saying ID1 has name Anjali and ID2 having name Shivam, then if we are giving ID1 again, then it is for sure that the name will be Anjali, right? Because ID defines name. This is what functional dependency means. So if we have given the ID is defining name, so everywhere in the table, if the rows like particular cell is having the same value like ID1, then for another row also the y will be same. Means here if they are having same x, then same y will be there. So here the left part is called determinant and y part, which is right one is will be called as dependent. So here functional dependency from x to y, means y is functionally dependent on x. So here employee ID, employee name, department ID and department name. Here this is our table where employee ID and department ID are unique. So employee ID and department ID will be the primary key here. So we can say employee ID defining employee name and department ID. So it means employee ID, if employee ID in two columns are same, if again one row is again having the same employee ID 101, then name and department ID will also be same as for before. So it will be again John and D01 because employee ID defining name and department ID, right? So employee ID uniquely determines the employee name and department ID because each employee has a unique ID. So, this is one of the functional dependency. Another functional dependency is if department ID is defining department name. So, if we have two department ID here same, you can see D01, then name will also be same for them, right? So, this is what the functional dependency means, a basic rule which every rows needs to follow for those attributes. Why these are so important? So basically, determining functional dependency is important to design database in rational model and in database normalization. So basically, we have learned about two forms, which is normalization, breaking down the larger tables into smaller tables, and denormalization, integrating those smaller tables into larger ones again. Right? The functional dependency along with the attribute domains are selected so as to generate constraint that would exclude as much data as inappropriate data as possible. So basically you can see this table, right? So employee ID, name, zip, state and city. So instead of going with the larger table, we have divided into smaller two ones, in which the one table we are maintaining employee ID, name and zip ID, right? Employee ID, name and zip ID, this, okay? This we are maintaining, and another table we are maintaining zip ID, state and city, right? So with the employee ID, so here we have functional dependency as employee ID is defining employee name. So with the help of employee ID, you can define employee name, right? And then again with the help of employee name, you can define zip. So with the help of employee name, you can find the employee zip. Okay, so with the zip, if you want to find other details like state and city, then in the another table you have to go where the zip will act as a foreign key, and then for other tables you can find the more details, right? Why we have kept a common thing in these two tables? So that because we know that if you are dividing the two tables, there should be one common attribute which needs to be same so that we can find out the relation. So with the zip ID here, zip is common, right? So zip through here, zip, we will go here in this table, and with the zip value we can find the state and city. So this is why functional dependencies are important to divide the table called normalization, and to again integrate the tables back for the denormalization, right? And why we are dividing it into smaller ones, basically maintenance will be easy and redundancy, remove the duplicacy things. That is why we are dividing the tables into smaller ones, and which we have already learned about first normal, second normal, third, fourth, BCNF and fifth normal form in our last lecture. So I hope you have already learned. If not, then I would request you to go to that video and learn that thing, then only move to these concepts. Next is trivial versus non-trivial functional dependency. So these are the two different types of functional dependency, in which trivial dependency says that if employee ID and employee name defining employee ID. So you can see that employee ID is already in left part, and employee ID and name is all defining employee ID. So it is not giving some extra information, right? So that is what it occurs when the dependent attribute this, right? Dependent attribute is a subset of the determinant. So dependent attribute is subset of determinant. So in this, in simple terms, it does not provide any new information, right? Because employee ID, we were already having it, we were already knowing it. So left part is that which we already have, and right part is we are finding the relation with the left part, right? So in the trivial, we do not have any new information, and trivial dependencies are always true, but don't necessarily add constraint to the database. So these are true basically. Obviously, employee ID is defining employee ID. This is true, right? But it is not giving any new information to it. But in case of non-trivial, it occurs when dependent attribute is not a subset of determinant. So basically, when right part is not a subset of left part. So in this, we are always finding the new information. Like if we have employee ID, left part we have, right? So with the employee ID, you can find employee name. So this is with this functional dependency, which is the basic formula, we can find the relation basically here. It will help us to find the new information. So this type of dependency introduces meaningful relationships between the different attributes. And non-trivial dependencies are useful for data design, and they help in defining relationships as well, which in case of trivial dependency, it is not possible because it is only giving the information which we are already aware of. So this is a basic difference between trivial dependency and non-trivial dependency. Now, let's see if X is defining Y, right? It does not mean that Y will also define X. How? If we have some employee ID, right? So here you can say employee ID says, employee ID, let's suppose we have 101 and it says the name will be Anjali, right? So it does not mean that every girl with name Anjali will have the same employee ID, because it might happen that there are two Anjali with their different employee ID, right? So this is what, if X determines Y, it does not mean that Y will also determine the X back, right? So this point you need to keep and you need to remember as always, right? So if X here, the X part, left part is determining Y. So, if it is like if Y part is not unique, right? It's not primary, then Y part can be duplicate, and duplicate value should not define any primary value, right? So this is how it works. So that is example like how employee ID can define employee name, but employee name cannot define the employee ID back. Now, what are inference rules? So inference rules are basically the rules that allow us to find new functional dependency with the previous one. So functional dependency, we have learned the rules like A defines B, right? AB defines C, right? So if we have these functional dependency, and from this, if in case we can say that B also defines C, right? So if we are finding some new functional dependency from the older one, then how we are finding? By following some rules, and that are called inference rules. So these rules help in reasoning out the relationship between the attributes and help in determining the closure of functional dependency, which is crucial for database normalization. So if in case, let's take an example of reflexivity. Basically, we have 7 different types of inference rules: reflexivity, augmentation, transitivity, decomposition, pseudo-transitivity, and self-determination. So about all these inference rules, we will be learning in our next slide. So as of now, let's try to understand what is reflexivity. So if Y is a subset of X, right, then we can say X determines Y. Okay, true. So if in case employee zip determines employee state, so with the zip you can say what is the state. Okay. With the zip, you can say city. With the zip, you can determine city also. Okay, so basically, this is determining state and zip is also determining city. Okay, now, both are true because employee zip determines both state and employee city, right? So basically, if zip determines state, and zip determines city, right? So zip employee state and zip determines employee city as well, right? So that is what if reflexivity says if x y is subset. Subset means, so it was like this: employee zip was determining state also and city also. So zip was determining both the things. So we can divide basically in two different functional dependency, like zip can independently define state also and city also instead of combinedly defining it, right? So this is what reflexivity means. Okay, now let's come to closure. So closure is nothing but it is a set of functional dependencies. So however number of functional dependencies are, let's suppose A define B, 1, B defines C, second, C define D. So let's suppose we have three different dependencies, right? A defines B, B defines C, and C defines D. So the group of set of these dependency will call as closure. So to this we call as closure, right? And we will denote as, instead of F, we denote as an F plus. Okay, so this is a set of all functional dependency. It includes all the functional dependency that can be inferred or derived from the initial set of functional dependency. So what happens with the with this inference rule, we know that we can find the new dependency, functional dependency as well. So let's take the example. If we define A defines B, B defines C, and A defines D. So this all functional dependencies we have. So if you will see this, A defines B and B defines C, if with using both this, if we can say A defines C also, right? So we have find one new functional dependency with the help of those inference rules, and now we have collectively, instead of 3, we have 4 closure, right? 4 functional dependency. So the set of these functional dependency, we can call it as closure. So we can compute the closure F plus using the inference rule. So A defines B, B defines C. We use with the help of this transitivity inference rule, which we will be learning, we can say A defines C also. So thus the closure will be A defines B, A defines C, A defines D, and B defines C, right? So this is what closure is, a set of set of all the functional dependencies, the previous one also or the new ones also, which we can find out with the help of inference rules. In the next video, we will be learning about all the different 7 types of inference rule, and that is all about the whole lecture for this one. I hope you learned. Now let's meet in another lecture. Till then, keep learning. Take care of yourself and your family too.